Notes these last two topics for our unit on absolute value. Kind of sort of interesting because we're going to take a look back here in 2.6 and then a look forward in 2.7 before we move on to a big concept with quadratics. But focus here is absolute values. So what we do want to do is take a look at this absolute value function right here. We have a graph. It actually displays, the graph's not the greatest graph in the whole wide world, but it does display what the vertex is. And so it's asking us to first write the following as an absolute value function. So some of the things that I kind of want to pinpoint here, of course, is our A, our H, and our K. It tells us what the vertex is, and our vertex has a K value of 7. Now remember that in this situation, our vertex is negative, our y-axis symmetry is -4. That's where we're changing those directions. We're going from an increasing interval to a decreasing interval. And then the A value does need to take a little bit here. For instance, I'm going to go ahead and find a point that I definitely know off to the right side. So I have a point at -4, 7, and I have a point at what looks to be 0, 5. And if I find the slope here, change in y over change in x, the change in y goes from 7 down to 5. The change in x goes from -4 to 0, so that's going up 4. And so our A value here would be -1/2 when I reduce -2 over 4. So with all that being said, I could write an absolute value function. We should definitely, absolutely be able to do this. So we have, did it again, -1/2 as the A value. Of course, that H is the tricky one. We see a -4 for the vertex. We want to go ahead and make sure that we have the inverse appearing there. And then I have a +7. So when asked to graph, or at least figure out the absolute value for this particular function, we would have y is equal to -1/2 times the absolute value of x plus 4 plus 7 as our answer. But as we go ahead and look backwards here, do want to consider the fact that this is an absolute value function, most certainly, but we can certainly take a look at it as a piecewise function as well. I do have an increasing interval, I have a decreasing interval, so we can see even the change of direction here. So it is a two-part piecewise function. I'm going to go ahead and start off what we did with piecewise functions. We have f of x. And with the understanding here, and this graph gets cut off at specific locations, just for argument's sake, let's go ahead and add arrows and suggest that this is going on forever and ever, so we don't have to worry about exact locations there, especially on the right side. For my intervals here, I'm going to say that the first piece goes from -infinity all the way to that vertex location at -4. And then for the decreasing interval, the second part of that, remember here I have to, if I put a line underneath that arrow with the -4 over here, I'm going to not do that, and that would be traveling off to positive infinity. So a little bit of flexibility with which of those arrows with the -4 are the ones that are going to get the line underneath it, but one of them does, one of them doesn't. Now I have to consider both these lines as a linear equation. I'm actually going to say the second one, and I'll go ahead and highlight here, and I'll highlight it in pink because it is the decreasing interval. That one is probably the easier of the two to do. That one is the one that probably looks the most like the absolute value function, with one consideration, which is we can certainly see the y-intercept here. So that is what I have highlighted in pink. That is definitely a linear equation. We already know the slope. We already know that we went down 2 and right 4 for our slope in that scenario. We reduce that to -1/2, and I can see in that the y-intercept is the number 5. So when it comes to the linear equation for the pink part of the absolute value, I have -1/2 x plus 5, because it hits at the y-intercept of 5. So I would say when we do this, especially if we can see one of them visually hitting the y-intercept, that's probably the easier of the two to focus on early on. But after the fact, we do have some other things that we need to take care of, which is the first part of this absolute value function, which is kind of like this. This one's tricky, but what I will say to you to start off with is that since we have matching locations, since I have this axis of symmetry here that we know about. Remember, that axis of symmetry is at that h value. The axis of symmetry is at -4. I do know I should have a corresponding piece opposite of 0,5, equidistant from that mirror. So there are certainly things that I can do to consider that. We could find this dot right here. That dot's kind of hanging out in no man's land in terms of the x value. We could go all the way here. I'm pretty sure that I have a location here, or a point that would be at -10.4 in this situation, and I could consider that in terms of the vertex. But when it comes down to it, our slopes, if we're looking at the value function, should be opposite slopes. And what I mean by that is if I consider the -10.4 and the -4.7 vertex here, the change in y, I'm going from 4 to 7. I suppose I'll go ahead and do this in blue. The change in y going from 4 to 7 is 3, and the change in x, we're going from -10 to -4, which is increasing by 6, and oh, look at that, 3/6 would in fact be reduced to 1/2. So when I'm graphing an absolute value function, I'm trying to write it out as a piecewise function, I should have opposite slopes, in this case 1/2 and -1/2. The only other question that's involved here is trying to see where this would go in terms of hitting the y-intercept. I did leave a little bit of space at the top there. We can most certainly count it out. We know every single time on this blue line that I would be going in a certain direction. Every time that I go up 1, I'm going to the right 2. So up 1 and to the right 2, that means that if I was at -4, if I was going to the right 2, I would then have a point at -2, and up 1 would be going to 8. And then if I would go one more point, and I'm traveling up here, I'm just trying to see where this would hit, locationally speaking, of course. Then I would go one more point, and that would go get me to 0, 10. And certainly in this picture, that's not the easiest thing to consider because the graph's not necessarily lined the greatest, but we can project where that would hit. I could even use slope-intercept form if you wanted to, but in this scenario, it would hit at 0, 10, so our y-intercept for that blue piece, even though we can't see it visually on the graphic, it's cut off by the interval, would be at 10. So taking an absolute value function, taking a look at that v, or in this case the upside down v because of the -a value, and being able to write it as a piecewise function, understanding the slopes should be opposite of one another, and then from there we just do exactly what we did in the previous topic.